we're going to see how to parametrize an ellipse in polar coordinates. We know that the parametrization of a cycle centered at the origin is x equals r cosine of theta and y equals r sine of theta. We know that a circle centered at the origin in rectangular coordinates are x squared divided by r squared plus y squared divided by r squared equals 1. Or you could say x squared plus y squared equals r squared. So, here, if you square x and y and add them, you have r squared cosine square of theta plus r squared sine square of theta equals r squared. For Pythagorean identity, you know that cosine square of theta plus sine square of theta is equal to 1. So here you have r squared that multiplies square cosine of theta plus square sine of theta equals r squared. This is 1, and you have r square r equals to square r. Or now, if the cycle is centered at the origin, we have this. We have x equals to r cosine of theta. What if it is not centered at the origin? So, if it is not centered at the origin, we have x minus h squared divided by r squared plus y minus k squared divided by r squared equals 1. So, we have, well, we know that cosine square of theta plus sine square of theta is equal to 1. The x coordinate would be, x minus h squared divided by r squared. This is the cosine square of theta. So, x minus h squared is equal to r squared cosine square of theta, and so x is equal to r cosine of theta plus h. The same for y. In y going to be, you can do it by yourself, what would be y equals r sine of theta plus k. This would be the parametrization of a circle not centered at the origin. Oh, well, centered at the origin is if k and h are 0. Because if you square the x and the y here, you would have again, well, let's do it actually in order to see that we have the result. So, well, first let me explain you why I put this. We have the circle. I have the x coordinate. Let's say this point. The x coordinate divided by the radius is cosine. If I have the x coordinate square divided by the r square, I have the cosine square. For that I did that equation. Alright, now, so y and x. So r square cosine theta square plus 2r cosine theta h plus h square plus, I'm running out of space, r square sine square of theta plus 2r sine theta plus k square equals r square. So, you can factorize the cosine square and the sine square. So, you have r square times cosine theta plus square cosine theta plus square sine of theta plus h square plus k square plus, here you can factorize the 2 and r, and so you have 2r times cosine of theta times h plus sine of theta plus k equals r squared. Alright, you can divide everything by r, and you will have, and here you have 1. So what you will have r plus h squared plus k squared plus 2r times cosine of theta h plus sine of theta k equals r. Actually, let's divide everything again by r. So this divided by r, like this, and here you have 1. Alright. Alright, this doesn't look like any equation familiar, but you can derive this from the parametrization of x equals this and y equals that. Alright, now what happened is, instead of having r and r here, we have a and b. So this is the ellipse centered at the origin. So in order to do that parametrization, we need to put x equals r, or x equals a cosine of b of theta, and y equals b sine of theta. Because what's let's say what's cosine of theta? Cosine of theta would be x divided by a, and here sine of theta would be y divided by b. First, let me do it in this cycle. When we have this parametrization, we have cosine of theta is equal to x plus h divided by r, and this same for sine of theta is y plus k divided by r. You square both sides, cosine square of theta plus sine square of theta, that's 1. And here, you have, I already took it away, but the equation of the cycle, I already put it. X plus h all squared divided by r squared plus y plus k squared divided by r squared, that's equal to 1. So we know that this parametrization of x and y is the parametrization of cycle not centered at the origin, or was centered at the origin if h and k are 0. Now for the ellipse. So we have cosine theta equals x divided by a, and sine theta equals y divided by b. So we have cosine square of theta plus square sine of theta equals 1. So x squared divided by a squared plus y squared divided by b squared equals 1. So we know that the parametrization of an ellipse centered at the origin is x equals I cosine theta and y equals b sine theta. If now we want to parametrize a ellipse not in the let's say not in the origin as the center, so we have x equals a cosine of theta plus h and y equals b sine of theta plus k. Again, now the cosine would be x minus h divided by a, and the sine would be y minus k divided by b. You square cosine and sine and add them, and so you have x minus h squared divided by a squared plus y minus k all squared divided by b squared equals 1. And so this, this is the parametrization of a ellipse centered at any point.